Hi, I will show you how I hacked a power adapter to a double clap switch. So this was the power adapter here. This is his box. And I thought there was some room in this box, and this is the original circuit, that I bet I could stick a little control circuit to make it a clap switch and have it in a nice box also. So this green circuit is what was inside originally. As you can see, it doesn't take the whole volume of the box, so I could exploit the space that is left to add my own little control circuit, which is the brown one here. Quick and dirty, custom made, PCB. So the idea was to use the 5 volt power supply that this adapter provides as the power source for my control circuit, and also tap in from the mains power line, which is here, through a relay here to switch on and off some AC powered stuff. So the idea is that the AC cord will be connected here, and there will be a AC output cord coming out from the back here, which will be powered, which will be controlled by a double clap. I've drilled some holes into this case to add a microphone to pick up the signal, indicator LED, which indicates if a clap has been registered, if the microphone heard like the clap, and some control knobs, one to control the gain of the amplifier, to adjust the sensitivity of the clap switch, and the second one is for the threshold, also increase or decrease sensitivity. Now both of those are essential, because if you increase the gain in this simple circuit, you also increase the noise that this power adapter generates, and it had quite a big ripple that caused a lot of problems, which I saw with the oscilloscope. So I had to modify a bit the circuit and add a big capacitor to smooth the ripple, which I had. I soldered it right here. There was some room for this. There's this capacitor I soldered, and I got it through the slot here, and I added some hot glue to insulate it to not make any short circuits. The big ripple this adapter generates is picked up by the microphone and then amplified with the LM358, and if you adjust the gain of the amplifier, the ripple is very big, and eventually it triggers the switch. So you have to adjust the threshold, which is simple voltage divider comparator, so that it would always be higher than the ripple, than the noise margin. It's possible that this adapter had such big ripple because of this capacitor here. It has a little bulge on the inside. I think maybe it's faulty or soon to be faulty. I would replace it, but I don't have a capacitor like this at the moment. So my solution was just smoothing out with the biggest capacitor I had, which is 470 microfarad. I checked with the oscilloscope, and the ripple was at a decent level. So right now I've assembled it, but I have not yet connected the mains, so it will not switch anything large power here. But basically I will tap the mains here through the relay and through an output cable here. I'll do it soon. Right now I can show you that it works. I'll demonstrate it with a simple LED. I'll also put it inside the box and see how it goes. So here's my little clap switch old rig. I've connected the output here to a multimeter to show you that it works. It switched on the AC mains. So it's connected here to the mains. It goes through the relay here. The little control circuit that I showed you earlier is inside. And well, let's test it. Here, you have to make a little noise. And that's the mains voltage. Now double clap again. And it falls. So what I need to do is to close the box and just make sure final things work before I close it. It's really nice. Mains. Yeah. And this is what happens if you clap once. Turns on the LED for a certain amount of time. When the LED is turned on, that's the time you have for the second clap. So if I clap once, nothing happens. Twice, switch on the AC voltage. Pretty cool, fits nicely into this box. And this power adapter had actually a lot of problem with the relay. When the relay is switched on, it drastically increases current consumption of the circuit and it affects the ripple. It just grows a lot. Might be, I don't know, because of some resonance feedback, whatever, with the coil and the power supply, or just because of the large current consumption. Something is wrong with the supply, but I still managed to make it useful. Also, when I tried to test it with a LED, I only connected a ground cable like this, only to the ground, and it was floating on the other side. And it actually, when I tried to turn it on, it wasn't able to hold the relay in the switch position. So something was wrong just by connecting this power supply. It reacts pretty bad to coils. After I removed the cable, it was very magnetic, so some interesting effects here. I forgot to mention that the main part that controls this circuit is the PEEK 12F683, which is the brains behind this control circuit. Previously I made a clap switch with two 555 timers and a JK flip-flop. It was much bigger. I have another video of it. And so with this microcontroller you're able to squish all of those functions into one little neat small control circuit. Also, I managed to fit it into this nice box. It looks much more slick. So there it is. All that's left now is to close the box and add this, extend a bit the cable and add this. And I'll be able to switch on and off some AC powered stuff, such as my lamp on the desk. So I'm gonna do it now. So this is the clap switch, all in the box, assembled. Right now what's connected to it is this lamp. It's connected to this connector. So let me demonstrate how it works. I'll just make some noise. So that turned it off. I should say I'm pretty disappointed with the result. I just can't get it to work as well as the previous claps which I built, because the ripple on this power supply is very bad. It's just horrible, and I can't increase the sensitivity enough for it to work from a longer range without having much problems with switching. So it's really a matter of the power adapter that you work with. This is my old clap switch which I built. It has a single board which I made, and this is the supply model. This one doesn't have a nice box to enclose it in, but it works much better. Actually, I was gonna make an enclosure for it to make it more safe. But this clap switch, you can see they both react, and my lamp usually was connected to this old clap switch, so I make a new one, but this power supply is pretty bad. So here's from a longer range. Already quite a bad delay, something with the switching. Well, the old clap switch works just fine. See? So it was fun making it fit this box and everything, but it's too bad that the adapter itself causes too much problems. And to solve this ripple problem would require a bigger circuit, or I don't know, something more. It might be a problem of fixing it. Well, if you can find a good power supply, you can make very nice clap switches like that. Well, this is it.